Okay, so today we're going to look at 8.4 on trigonometry. Trigonometry really just means looking at the ratios within a right triangle. And so we're going to look at three of the main trig ratios. They are sine, cosine, and tangent. Again, we call these the trigonometric ratios. And that's where we compare the lengths of the sides of a right triangle. So here we have a right triangle, triangle ABC, and we'll see, each angle we have a capital letter, and then directly opposite is the corresponding lowercase letter. So opposite angle C is side C, and so on. So the way we define these trig ratios, so the first one we'll look at is called the sine of A. Actually, let me write in here. For sine, cosine, and tangent, we use the first three letters as the abbreviation. So you'll see down here, it'll say the trig ratio, sine of A. So we write that S-I-N, and then we put A. This, whatever comes directly after the sine, cosine, or the tangent, this is always referring to an angle. And the sine is defined as the leg opposite angle A over the hypotenuse, that ratio. So let's just look at, here's angle A. The leg directly opposite would be side A. The hypotenuse would be C. And then we say the leg adjacent would be B. So if the sine of A is defined as the leg opposite over the hypotenuse, then we put A over C. The cosine of A is the ratio of the leg adjacent to angle A over the hypotenuse. So that's where we get B over C. And finally, the tangent is the leg opposite angle A over the leg adjacent angle A. So that's going to be A over B. So we have this term SOHCAHTOA. It's not a real word, but it helps us to remember the order and the definitions of the trig ratios. So if we kind of split these up into three different parts, we have SOHCAHTOA. So is sine, is equivalent to the ratio opposite over the hypotenuse. Next, we have CAH, that represents the cosine is adjacent over hypotenuse. And finally, tangent, the last one, is the opposite over the adjacent leg. So remembering this word SOHCAHTOA just, again, helps us to remember the order and the definitions of the trig ratios. So example number 1, we want to find the sine of R, cosine of R, tangent of R. And then we're going to look at sine of S, cosine of S, and tangent of S. When we, in geometry, for right now, we're just going to look at acute angles. So I'm never going to ask you for the sine of angle T in this example number 1, or the cosine of angle T, or the tangent. That's something that we'll get into next year in Algebra 2. So first thing, I'm going to just write down SOHCAHTOA, just as a reminder of the order. And we're going to look at these first three. We're going to look at sine of R, cosine of R, and tangent of R. So the first thing you want to do is identify the angle that we're working with. So we're working with angle R, and it's helpful to identify the opposite, the adjacent, and the hypotenuse. Well, hypotenuse is always easy because that's directly opposite the right angle. Opposite angle R would be 4, and adjacent to angle R would be 3. So remember, what we're going to do is we're going to express each ratio, we're going to express it as a fraction and as a decimal rounded to 4 decimal places. So the sine of R, so again we go back to SOHCAHTOA, sine is the opposite over the hypotenuse, so that's going to be 4 over 5. Now on your calculators, we want to basically put 4 over 5 and we want to change that to a decimal. Of course, when I put 4 divided by 5, it just turns it into a fraction. So I'm going to show you 3 different ways. One is if you press menu, go to 2, and then number 1, convert to a decimal. It will write that as 0.8. Another way to do this is 4 divided by 5, and then right above the enter sign is a squiggly equals. So if we press the control button, oops, looks like I have an extra division, so let me just delete that. Oops. So now if I do control enter, that will turn it into a decimal, it'll approximate it. And then one more way, if I just put 4 point divided by 5, 4 point divided by 5, it will read this problem as wanting a decimal because I put a decimal in the problem, so that's why I changed it to 0.8. So we'll write in here 0.8. Next we'll go cosine. So cosine is the middle one, CAH. Cosine is adjacent over hypotenuse, so that's 3 over 5. Plug that into your calculator and you'll get 0.6. Then we'll have tangent of R. So tangent is opposite over adjacent, so that's 4 over 3. And then when you plug that into your calculator, you get 1.3 repeating, and we want to go to 4 decimal places. We're not going to put the line above it. We still want to write it out to 4 places. Okay, next we're going to look at the sine of S, the cosine of S, and tangent of S. So now I'm going to focus on this angle. Now the hypotenuse doesn't change, but in relation to that angle, the opposite side is now 3 and the adjacent side is 4. So now when we do sine of S, we're going to put 3, because that's opposite, over the hypotenuse, which you'll notice is the same as cosine of R, which makes sense. We just switched the places. Next, we want cosine of S, so cosine, CAH, that's adjacent over hypotenuse, so that's going to be 4 over 5, which is 0.8. And finally, tangent of S, that's going to be opposite over adjacent, 3 over 4, which is 0.75. Okay, example number 2, we want to use a calculator to find each value, round to the nearest 10,000th, which is 4 decimal places. Okay. If you look at my calculator up in the right-hand corner, it says degree. Yours probably says radian. So we want to change your calculator settings so that it's in what we call degrees. So you're going to go press the on button to go to your home screen. You're going to press number 5 for settings, number 2 for document settings. Now you'll see where it says angle. We want to change that to degrees. So just go ahead and use your arrows to go down, change that to degree. And what the important part is you want to make default. So at the very bottom, all the rest of the settings are fine. You just want to change the angle to degree. So you want to make the default. Now it's going to ask you, do you want to apply this? You're going to click OK. And now when you press the calculator button to go to your scratch pad, it should say degree. Now we want to type in sine of 57. So you're going to go to your trig button, and you'll see here sine, cosine. We'll see all of our buttons. So you're going to press sine, and you're going to type in 57. Oops, having some calculator issues. So we're going to type in sine of 57, press enter, and we're going to round that to 3 decimal places, so that's going to be 0.8 387. Next, go back to the trig, and we want to press cosine of 60 degrees. So that's 0.5. Tangent of 30 degrees is 0.5774. And sine of 85 is 0.9962. Okay, so now we're going to kind of combine these last two examples into finding a value of x. So here we have a right triangle. We know one side and we know an angle. So first, I'm going to go back to this SOHCAHTOA, because that's going to help us determine which ratio, sine, cosine, or tangent, we're going to use in order to solve this. So the first thing, just kind of identify, we're always going to, remember I said we're always going to work with the acute angle, so that's going to be the 24 degrees. And then we want to identify the two sides that we're working with in relation to that angle. Well, I'm trying to find the opposite side, and I know the adjacent side. So I look back to SOHCAHTOA, which one has the opposite and adjacent, and that's tangent. That's the last one, TOA. So I'm going to write tangent. Now remember, we said we always put the angle right after the trig ratio. Well, that's where we're going to put the 24 degrees. Equals OA, so we need to put it in that order, opposite over adjacent. Now I want to solve this equation for x. Well, think about how would I isolate x? I would multiply both sides by 19. And then we'll get x equals, so we want 19, and then times, we want tangent of 24. So we get, and then here we want to round to the nearest 10th place, that's going to be 8.5. Now you could have put in the tangent of 24 and then times 19, but you have to move your arrow over because you don't want to have the times 19 inside the parentheses. So you'll notice we'll get the same answer there. Okay, let's take a look at the next example. So again, identify the angle we're working with and the two sides that we're working with. So this is the, oops, not the opposite, the hypotenuse. And x is the leg adjacent. So adjacent and hypotenuse, that's the middle one, that's cosine. So we're going to write cosine of the angle, so that's 62 degrees, equals adjacent over hypotenuse. So we're going to multiply both sides by 60. Type that into your calculator, so do 60 times the cosine of 62, and we get 28.2 for x. Okay, use a special right triangle to express each trigonometric ratio as a fraction. So I'm working with tangent of 30 degrees. Well, we are either working with a 30, 60, 90 or a 45, 45, 90. In this case, it's a 30 degree. So I'm going to draw the 30, 60, 90. And recall that we label this as x. That's the shorter leg. The hypotenuse is 2x. And the longer leg is x root 3. So if I want the tangent, remember, SOHCAHTOA, tangent. So if we go back, tangent is opposite over adjacent. So here's my 30 degree angle. Opposite is x. Adjacent is x root 3. Now the x's are going to cancel, but I still have a 1 in the numerator, so it's really 1 over root 3. And then when we go to rationalize, we're going to multiply by root 3 over root 3, so we get root 3 over 3. Okay, next one. Now I want to look at the sine of 60. So we're still working with a 30, 60, 90 triangle. So here's 60 degrees. So 60 degrees, we want sine, so that's opposite over hypotenuse. So opposite is x root 3 over the hypotenuse, which is 2x. The x's are going to cancel, and I'm left with root 3 over 2, and we don't have to rationalize because the radical's in the numerator. Okay, so sometimes we don't know the angle measure. So in other words, let's say we want to find the angle measure. We know what the sine, cosine, or tangent is equal to. So here we have an equation. Sine of A is equal to 0.4325. So how do we solve for A? We use what's called an inverse trig function. Just like if you had 2x equals 10, what would you do? You would divide. The inverse of multiplication is division. So the same thing's going to happen with trig ratios. But the way we write it is, it kind of looks like an exponent of -1. It's not an exponent. It's the way that we write the sine inverse. And so basically the sine inverse and the sine cancel each other out, and we're just left with the measure of angle A. So if you go to your calculator and you go to your trig, you'll see right underneath the sine is the sine inverse button. So that's where we're going to put 0.4325. And then press enter, and we get 25.6 degrees. So we can basically find the angle measure for using sine inverse, cosine inverse, or tangent inverse, depending on what we are provided with. So here, tangent of A, let's look at example 5. Find the measure of each angle to the nearest tenth of a degree. So tangent of A is equal to 1.4176. We take the tangent inverse of both sides, and you'll notice I don't even write that step down. I'm just going to write, basically, when I move the tangent to the other side, it really is taking the tangent inverse of 1.4176. So go ahead and type that into your calculator. Go over to tangent inverse, 1.4176, and we get 54.8. And again, this is the nearest tenth of a degree. Next one, we want to find B. So B is equal to the sine inverse of 0.6307. So type that into your calculator, and we get 39.1 degree. Okay, our last example, we're going to now apply this, and we're going to think back to our SOHCAHTOA again. So this is the angle I'm looking for. So just like we did previously, we want to identify the two sides that we're working with. Here we have 15, which is opposite, 6, which is the adjacent side. So that has to be tangent. So it's tangent of the angle. Well, the angle is what I'm looking for, so I'm going to put tangent of x equals OA, so opposite over adjacent. Now that can be reduced, but I honestly wouldn't worry about doing that. I would just go right to x is equal to the tangent inverse of 15/6. So tangent inverse of 15 divided by 6, press enter, and we get 68.2. So that's 68.2 degrees. Okay, in the next example, here's our angle. We have opposite, we have adjacent, so this happens to be tangent again. So tangent of x equals 7 over 13. So x is equal to the tangent inverse of 7/13. And we get 28.3. So that's 28.3 degrees.